guys, today topic is rate limiter. What is rate limiter? A rate limiter is a mechanism used to control and limit the rate which certain actions or requests can be made within a system. It sets predefined limits on how many times specific operation can be performed within a given time period. Rate limiting is a commonly used in computer systems, web applications, APIs, application programming interfaces, and network services to prevent abuse, protect against malicious activities, manage resource allocation, and ensure fair usage. Here's how rate limiter typically works. First one, requests or actions. The rate limiter tracks the number of incoming requests or actions being made by the user or clients. Second one, limit definition. A limit is defined specifying the maximum number of requests or actions allowed within a certain time frame. For example, it could be set to allow 100 requests per minute. Third one, tracking. The rate limiter keeps track of the number of requests or actions made by each user or client, typically using techniques such as counters or timestamps. Fourth one, enforcement. When a user or a client exceeds the defined limit, the rate limiter takes action. This can involve delaying, throttling, or rejecting sufficient requests until the rate drops below the allowed threshold. Rate limiting helps you prevent system overload, protect against DOS, denial of service, attacks, ensures fair usage among users, and improves overall system stability and performance. There are different approaches to rate limiting, such as fixed window, sliding window, token bucket, or leaky bucket algorithms, each with each with its own advantages and trade-offs. The specific implementation depends on the requirements and characteristics of the system or application where rate limiting is being applied. These are the algorithms. Rate limiting can be implemented using different algorithms, and each of them has distinct pros and cons. Even though this chapter does not focus on algorithms, understanding them at high level helps to choose the right algorithm or combination of algorithms to fit our use cases. Here is a list of popular algorithms: token bucket, leaking bucket, fixed window counter, sliding window log, sliding window counter. First one, token bucket. The token bucket algorithm is a popular method for rate limiting in a computer networks and systems. It is used to control the rate at which requests or actions can be performed. Let's explain the token bucket algorithm with a real-time example. Examine a scenario where you have a Imagine a scenario where you have a web API that allows users to make requests to fetch data from a server. To prevent abuse and ensure fair usage, you want to implement rate limiting using the token bucket algorithm. This is the token bucket. We'll see next slide. The token bucket. Visualize a bucket that contains tokens. Each token represents the permission to make a single request. The bucket has a maximum capacity. Token generation. Tokens are generated and added to the bucket at a fixed rate over time. For example, let's say the bucket is configured to generate 10 tokens per second. This means that every 100 milliseconds, one token is added to the bucket until it reaches its maximum capacity. Requesting processing. When a user makes a request, the system checks if there are available tokens in the bucket. If there are tokens, one token is consumed for the request and the request is processed normally. If there are no tokens available, the request is either delayed or rejected, depending on the specific implementation, token consummation, and expiration. Each token has an expiration time associated with it. If a token is not used within a certain time frame, it's considered as expired and removed from the bucket. This prevents users from accumulating excessive unused tokens for future uses. Burst behavior. The token bucket algorithm allows for bursts of requests if the bucket has accumulated more tokens than its maximum capacity. Those excess tokens can be consumed in a burst, allowing a temporary increase in a request rate. However, once the burst tokens are depleted, the rate returns to the predefined limit. The token bucket algorithm provides a flexible and predictable way to control the rate of requests. It allows bursts within a defined limits while ensuring that overall rate is maintained over time. In our example, if if the bucket has capacity of 100 tokens and of 10 tokens per second, users can make up 10 requests per second, but they can exceed the burst of capacity of 100 tokens. If the bucket is full, users need to wait for new tokens to be generated before they can before they make the additional requests. The second algorithm, leaking bucket. The leaky bucket algorithm is another method used for traffic shaping and another rate limiting in computer networks and systems. It controls the rate at which data or requests are allowed to pass through a system. Let's explore the leaky bucket algorithm and its types, with a real-time example. The leaky bucket algorithm. Imagine a scenario where you have a network router that needs a control outgoing traffic to ensure it doesn't exceed a certain rate. The leaky bucket algorithm can be used to achieve this. First one, the leaky bucket. Visualize a bucket that can hold a fixed amount of data or requests. Incoming data or requests are poured into the bucket. Second one, leaking or dripping. The bucket has a leak or a hole from which the data or request drip out of a predefined constant rate. This rate represents the maximum allowed rate of outgoing traffic. Third one, bucket overflow. If a incoming data or request arrive faster than the bucket can leak or drip them out, the bucket will start to fill up once the bucket reaches its capacity. Any additional incoming data or request will be overflow and discarded. Fourth one, drip rate. The rate at which the bucket leaks or drips the data or request in is constant, regardless of whether the bucket is full or empty. This ensures a constant outgoing rate. Types of leaky bucket. There are two types: constant leaky bucket and variable leaky bucket. Constant leaky bucket. In this type, the leak or drip rate remains constant over time, regardless of the current fill level of the bucket. The data or requests leak out at the same fixed rate. This ensures a constant rate of outgoing traffic. Variable leaky bucket. In this type, the leak or drip rate can be varied based on the fill level of the bucket. If the bucket is almost empty, the leak rate might be slower, allowing for some burst behavior. However, if the bucket is close to being full, the leak rate may increase to prevent overflow. Real-time example. Let's say you have a network interface with a maximum outgoing bandwidth capacity of 100 Mbps megabytes per second. To ensure that the outgoing traffic does not exceed this limit, you can implement the leaky bucket algorithm. The bucket represents the interface buffer or queue, which can hold a certain amount of data. This leak or drip rate is set to 100 Mbps, meaning that outgoing traffic rate should not exceed this value. Incoming data or requests are continuously poured into the bucket. If the incoming traffic rate exceeds 100 Mbps, the bucket will start to fill up. Once the bucket reaches the capacity, an additional incoming traffic will overflow and be discarded. The rate remains the constant at 100 Mbps, ensuring that the outgoing traffic is always within the defined limit. By using leaky bucket algorithm, you can regulate the traffic flow, prevent network congestion, or exceeding the maximum allowing rate. Fixed window counter. The fixed window counter is a simple approach to rate limiting that counts the limit number of events or requests within a fixed time window. Let's explore a real-time example of the fixed window counter. Imagine you have a WebView API that allows users to send SMS messages to prevent abuse and enforce rate limits. You decide to implement rate limiting using the fixed window counter. First one, rate limit definition. You set a rate limit of 100 SMS messages per hour for each user. This means that if within a rolling 1 hour window, a user can only send up to 100 SMS messages. Fixed time window. The fixed time window is 1 hour starting from the current time and moving backward. For example, if it's currently 10 o'clock a.m., 10 a.m., the window would be from 9 a.m. to 10 a.m. Third one, event counting. Whenever a user sends an SMS, you increment their counter for the current time window. For instance, if your user sends 3 SMS messages at 9:30 a.m., their counter for the timer window would be 3. Fourth one, rate limit check. Before allowing a user to send an SMS, you check their counter for the current time window. If the counter exceeds the rate limit 100 messages, you reject the request or take appropriate action such as delaying or throttling the request. Fifth one, the time window sliding. As time progresses and current time window moves, you update the counter accordingly. For example, at 10 a.m., the previous time window from 9 a.m. to 10 a.m. expires and a new window from 10 a.m. to 11 a.m. starts. The counter for the new window is reset to 0. In our By using the fixed window counter, you ensure that users can exceed the specified rate limit within a fixed time window. In our example, a user can send up to 100 SMS messages within a rolling 1 hour period. If if the attempt to send more messages, their request will be rejected or handling according to your defined policy. This rate limiting mechanism helps to control the rate of SMS messages being sent, prevents abuse, ensures fair usage, and protects the system from being overwhelmed by excessive traffic from a single user. Fourth one, sliding window log. Sliding window log algorithm is a constant context of rate limiting. We can combine the concept of sliding window and log-based rate limiting to create an algorithm. Let's explore a potential implementation. First one, sliding window. Define a fixed size, the time window that slides or moves over time. For example, let's consider a sliding window of 1 hour. Log. Second one, log. Maintain a log that records the timestamps of incoming events or requests. Each entry in the log represents an event occurrence. Third one, Rate limit check. When a new event or request arrives, check the log within the sliding window to count the number of events that occurred within the last frame. Fourth one, sliding window. Movement as time progresses, remove outdated entries from the log that fall outside the sliding window. This ensures that only events with the defined time window are considered for rate limiting. Fifth one, rate limiting enforcement. Compare the count of events within the sliding window against a predefined rate limit. If the count exceeds the limit, take appropriate action, such as rejecting the request or applying a rate limiting policy. Thanks for watching. Please subscribe.